is a number 4, which is the circuit diagram, no? Ito po yung last po na discussion po natin. So let's continue already with the loads, no? Or if that is unity power factor, if that is lagging power factor, or if that is leading power factor, no? This is the phasor diagram of a synchronous generator, no? So if this is our IA, and this is the EA, nagtataka siguro kayo bakit hindi diretso, no? So ang kino-consider lang po natin dyan is the IARA or the armature, no? If that is unity power factor, ayan po siya, at saka yung IA po natin. And then this one naman is the lagging factor, lagging power factor. That's why you can see here, bumaba po yung angle po natin or yung direction po ng angle po natin pababa. Since we assume na kapag lagging, pababa po siya. While leading naman, sa leading naman natin na power factor, pataas. No? So, ito na po yung pataas. So, kung mapapansin ninyo dito, naka 90 degrees palagi yung XS IA po natin. Noted po. Yan. So, kung mapapansin po ninyo, naka 90 degrees dyan yung XSIA po natin. Naka 90 degrees siya with the IARA po natin. Ayan. And also for the leading, no? So for a given phase voltage at saka yung armature current po natin, a larger internal voltage EA is needed for lagging loads than the leading loads, no? So thus, a larger field current po natin is needed to get the same terminal voltage because EA natin, K flux omega, wherein yung omega natin should be kept constant at a constant frequency. So, other than that, for a given field current and the magnitude of a load current, the terminal voltage is lower for a lagging loads and higher for the leading loads. So mapapansin nyo naman, no? Base pa lang dyan sa may figure natin, yung EA natin dyan, dito sa lagging power factor, no? Ito, sa tingin ninyo, ano ang mas malaki? Yung mas malaki ba yung angle niya or yung mas maliit ang angle? Based on your experience lang sa calculation nyo ng mga resultant forces. Terminal voltage. EA. So yung terminal voltage natin, mas mababa siya para sa lagging loads po natin tsaka mas malaki sa leading loads. So let's go with the power and torque of synchronous generators, no? So usually, pag mga generators, ang kinakalculate po natin dyan is power and torque, no? So the torque needed to rotate for the shaft, no? So ito po yung power flow diagram po natin for a synchronous generator, no? So we have there the P-input po natin. Before pa man siya na ma-convert to electrical, magkakaroon po tayo ng stray load losses, friction and windage losses, core losses, and P-converted. And before siya magko-convert ng P-output, we have there the I squared R, or that is what we call the copper losses. Or yung P-out po natin, it can be calculated as square root of 3 V terminal multiplied by I line cosine theta. No? And we have here now the input. Ayan. The torque applied multiplied by the rotation. And so, meron tayong losses dyan. That is the stray losses, friction and windage losses, core losses. No? And P converted po natin, that is equal to 3 EAIA cosine of gamma. Wherein ang gamma po natin is that is the angle between the EA or the phase voltage tsaka yung armature current po natin. So before siya magkaroon ng P output, we have there the copper losses. And P output po natin that can be calculated as 3 VT terminal voltage multiplied by I line cosine theta, or it could be calculated as 3 times of the V phase IA cosine theta. So sa Q naman po natin, pwede rin siyang makalculate as square root of 3. So mapapansin po ninyo, mali po yung naka-input dyan. This should be Q. Q out. So if you're going to simplify it in phasor diagram, ito po yung magiging simplification po natin. Ayan. So the phasor diagram is an assumption made whereby the armature resistance RA is considered to be negligible, and assuming, ano ibig sabihin ng negligible? Hindi na po siya added or parang tinanggal lang siya, no? If you're going to assume that the connected load is lagging in nature, no? So if this gives, no? Ito po yung magiging phasor diagram po natin. So ito po yung EAIA, that is the gamma. That is the angle between EA at saka si IA. And then we have there now the theta. Ito po ang theta po natin. Galing po siya kay difference ni IA at saka V phase. Yun po yung theta po natin. Maganda po no na you're going na kabisaduhin yung phasor diagram. Kasi very helpful po ang phasor diagram kung hindi po ninyo siya ma-visualize. Yan po yung theta. It could also be from this one, yung angle this one. Ito yung theta rin lang. Kung magna 90 degrees ka dyan, V phase, and 90 degrees ka dito. No? Okay na po. Next po tayo. So based upon the simplified phasor diagram, pwede daw po nating makuha na yung IA cosine theta is equal to EA sine, eto, from this equation alone. Nakikita po ba yung cursor ko? Ayan. From that equation alone, pwede nating i-simplify yan, no? So EA natin sine of the sigma over the XS. Ayan, from this equation alone. Galing siya yung EA po natin, sine of gamma, since they are adjacent. Okay, so ang ginawa po dito no is small triangle tsaka yung malaking triangle, ayan. Yung malaki na triangle natin na EA at saka yung maliit na triangle natin na JXS at saka si IA, kung maglalagay ka dito ng height niya, pwede mo siyang i-equate. Nasusundan po ba? Yes or no? Nasusundan po ba? Kung paano nakuha yung EA sine of sigma is equal siya sa XSIA cosine theta. Nasusundan po ba? Pakisabi kapag yes or no para alam po natin kung anong gagawin natin. Nasusundan po ba? Yes or no?
Ma'am, bali po yung EA sin sigma po, yung height lang po yung kinukuha niya doon?
Yung height lang. Tapos doon naman sa XSIA cosine theta, ginamit niya yung cosine identity. Para ang magiging equation niya is, kumbaga, since adjacent naman siya sa theta, cosine ang gagamitin mo. And then yung sine naman, since naka-opposite siya, opposite niya yung gamma, sine ang ginamit niya. Ay, intindihan?
Yes, ma'am.
Okay, so, okay na, no? Any questions, clarification? Wala naman? which gives another form of expression. So RA natin is assumed to be 0. So ang P ngayon natin can be calculated as P is equal to 3 V phase EA sine of sigma over XS. Ayan, pinalitan lang niya yung I cosine theta. Dito naman, ang ginawa niya, pinalitan lang niya yung I cosine theta dun sa equation natin na P is equal to V phase I phase cosine theta. Ayan. Eto, pinalitan lang po niya yung IA cosine theta. Naintindihan po ba? Ayan. Sinubstitute niya yung value na yan dito. Ayan. Since ang IA cosine theta natin can be solved from EA sine of sigma over XS. Ayan. So, pinalitan niya ngayon dito. Ayan. Naintindihan po ba? Naintindihan po ba? Yes or no?
Yes, ma'am.
Okay. So, from the above equation, it can be seen that the power is dependent upon, no? So, ano yung angle ng sigma natin? So, ang sigma natin, that is the angle difference between the VA at saka EA. Tama? Ito po siya. Similar siya with, hindi siya similar kay gamma kasi yung gamma natin, yun yung pinakamalaki, no? So, yun yung sigma po natin. Yung angle difference between the V phase tsaka si EA natin. Ito po siya kung nakikita ninyo. Ayan. Yan po ang kukunin ninyo na angle based on our phasor diagram, no? And then, ang sigma natin is known as the torque angle of the machine, no? So, the maximum torque can be found when sine is equal to 0, which gives the maximum power or the static stability limit to be, no? Kung ang sine natin is equal to, sigma natin is equal to 0, so kailan nagiging 1 ang sine natin if the angle is, if yung angle po natin is equal to 0 or 90. Kailan magiging sine is equal to, sine of the angle is equal to 1. That is equal to
90,
sine
ma'am.
90. Tama? Ayan. Tama po yung sinabi niya, no? So that is sine of 90 or that is the maximum torque po natin, no? So kung magiging sine 90 po yan, so ibig sabihin magiging 1 na lang si sine of sigma, no? So ang matitira na lang natin dyan is the Pmax, which is 3V phase EA over XS. Tama ba? Nakakasunod pa rin po ba? Yes or no, no? Okay, so if you're going to continue yung basic torque equation po natin wherein T induced is equal to KBR of BS, that is equal to B net, no? Or yung magnetic field, the total magnetic field po natin, which is equal to KBR B net sine of sigma. So alternatively, the expression can be derived from the expression which is P out natin is equal to P converted. So pwede din natin siyang ma-derive from P out is equal to P converted, wherein ang RA natin is assumed to be 0. No? So from the power diagram po natin kasi, sa power flow diagram po natin, balikan lang po natin siya eto. Ayan. So kung yung RA natin is equal to 0, ibig sabihin, ang core losses natin or the copper losses natin is 0. Tama po ba? Ayan. Kaya ang P converted natin, that is equal to P output. Since nag-assume tayo na 0 ang RA po natin. Naintindihan po ba? Naintindihan?
Yes, ma'am.
Okay? So if that is the case, so P converted natin is equal to T induced omega. So that is equal to T induced po ngayon natin, that is equal to 3V phase EA sine of sigma over omega MXS. So galing din lang po siya dito Sa taas, P. P output. Yan po yung P output po natin. Ayan, so kokopyahin nyo lang po yan. And then substitute nyo sa equation po natin. Ayan, sa equation po natin, papalitan nyo lang yan ng P converted. So, makukuha nyo na yung T induced, which is T of V phase IA sine of sigma over omega MXS. Doon po siya na-derive. Any questions, clarifications? May tanong po ba? Any questions po? So if no more questions, we have number 7, no? Measuring the synchronous generator model parameters, no? Paano natin ngayon ma-measure yung model parameters po natin? That could either be open circuit test or it could be short circuit test, no? Yun lang po yung gagamitin natin dyan. So basically, the 3 types of relationship which needs to be found in a synchronous generator is the field current, the flux relationship, and the synchronous reactance, the armature resistance. No? So how are we going to perform the open circuit test? No? Steps. We have generator is rotated at the rated speed. Ano po yung ibig sabihin ng rated speed? Ano pong ibig sabihin ng rated speed? May ibig sabihin po yan. Ang rated speed po is, for example, that is a 4-pole machine. 60 Hertz. Ano ang speed mo dyan? What is the speed of a 4-pole 60 Hertz machine? Anyone?
1,800 po.
Ayan, 1,800. That is, you're going to use the F is equal to Pn over 120. So 120 times 60 and then divide nyo siya by 4. So that is equal to, according to Ms. Nerissa, that is equal to 1/8. Tama? Tama po ba?
Yes po.
Okay, so if that's 1/8, so that is the rated speed. So parang yun na yung ibig sabihin niya ng rated speed is, if you're going to calculate from that formula, yun na yung speed na gagamitin mo. So if that is 2-pole, 60 Hertz, so 3,600 yata yan. So 300, 600. Parang kumbaga hindi, kung tutuusin yun na yung maximum na speed niya. Pero meron pa kasi yung iba na pwede nyo pang lakasan yung speed niya. Pero dun sa pagkatapos na kasi ng 3,600, there is a tendency na masisira kasi yung machine. So yun yung rated. Nagkakaintindihan po ba tayo? Kaya hindi ko siya tinerm as same with maximum speed kasi merong mga cases na pwede mo siyang paandarin ng mas mabilis pa kaysa sa 3,600. Nag-e-exceed siya sa rated speed. Ang tendency po nun pwedeng masira yung machine natin. Magkakaintindihan po ba tayo?
Yes po, ma'am.
Yan. No? So, no load is connected at the terminal. So, ibig sabihin, wala kang load na i-connect sa terminals. Yun lang, no? So, kung yung generator, paandarin mo lang siya, then patakbuhin mo siya dun sa rated speed niya. No? And then sa terminals, wag kang maglalagay ng load. Field current is increased from 0 to maximum. So, that's potentiometer, I assume, no? I-increase mo yung field current mo to the maximum daw. And then record the values of terminal voltage and field current value. So with the terminals IA, kapag naka-0 at saka yung EA natin equal siya sa V phase, no? So kung mapapansin po ninyo dito, bakit equal ang IA na ang EA natin tsaka si V phase again? Bakit equal sila dito? Since
No load, ma'am.
tama si Mr. Miguel, no? Since wala kang load na kinonect, no? And then, it is thus possible to construct a plot for EA at saka si VT, no? EA or VT versus the IF graph, or that is the field current, no? So this plot is called the open circuit characteristic, or ito yung term natin, OCC of a generator. With this characteristic, it is possible to find the internal generated voltage of a generator for any field current. Ayan. So ito na po yung kung gagawin ninyo yun, no? And may mga gamit kayo na pag-measure, ganun. So, ayan na po yung magiging curvature natin. Oh, meron tayong air gap line dyan. So, at first, the curve is almost perfect linear. Makikita po ninyo dyan, no? Parang mag-i-straight line siya until some saturation is observed at high field current. Nagsasaturate na or pupunta na siya sa maximum. Then the unsaturated iron in the frame of synchronous machine is reluctance several thousand times lower than the air gap reluctance. So, at first, almost all the MMF across the air gap and the flux resulting flux increase is linear. So when the iron finally saturates, then the reluctance of the iron increases dramatically and the flux increases much more slowly with the increase of the MMF. No? So the linear portion of the OCC is called the air gap line of the characteristic. So yun, bago pa man siya magsasaturate, ito po yung air gap line po natin. Kakaintindihan po ba tayo? Okay, so let's move on with the short circuit test. May tanong po ba sa OCC? Any questions with OCC, open circuit test characteristic? Okay, so let's move on with the short circuit test. No, the generator is rotated to speed, rated speed again. No, adjust the field current to 0. 0 lang po ang pipiliin po ninyo. Short circuit the terminals. Paano pong ibig sabihin ng short circuit? Anong gagawin nyo pag mag-short circuit po kayo? Ano pong ibig sabihin ng short circuit? Or ano ang gagawin mo para ma-short mo siya? You're going to anyone? Mr. Salom, anong gagawin mo pag mag-short ka? You're going to short. Hindi yung shorts ha, na shorts na sinusuot, no? Or hindi. Anong gagawin mo pag mag-short ka? Short mo man di circuit, kitain ta na dati power na kunada.
Pinagdidikit po ba yung...
Yes, pagdikitin niyo yung mga wires niya or yung terminals niya. Yun yung ibig niyang sabihin. So measure the armature circuit of the or the line current of the field as the field current is increased. No? So you have to note here that during the short circuit analysis, the net magnetic field is very small. So hence the core is not saturated. Hence the reason why the relationship is linear. Yan po yung relationship niya. Linear. Straight line lang po siya. Yan po yung ibig niyang sabihin. So mapapansin po ninyo dyan, ang minimeasure po ninyo or yung kinukuha niyong value is the IA. And then the other one is the terminal voltage. No? Okay? So, next, SCC is essentially straight line. To understand why the characteristic is a straight line, look at the equivalent circuit. When the terminals are shorted. So kung i-short mo yan, magiging 0 ang V-phase mo. So when the terminal short circuited, the armature current po natin is equal to, parang magsiseries na ang, ayan, tama, no? So ang EA po natin or the IA po natin is equal to EA over RA plus JXS. Tama? Tama po ba yung circuit niya? So kung kukunin nyo ang value ni EA, so sa magnitude po niya, since magnitude ang pinag-uusapan, kunin nyo ang square root ni RA squared plus XS squared. Or that is the magnitude of, magnitude po yan ng Z po natin. No? So for the phasor diagram of the corresponding magnetic fields, ayan, B phase natin is equal to 0, EA. We have there the IARA, JXS. So dun naman sa magnetic field po natin, ito po yung direction natin sa E-stat, B-net natin, tsaka si BR. Kung kukunin nyo si B-net, you're going to add the B-stat and BR. Depende po sa angle po nila, no? And so since BS is almost cancels the BR, tingnan po natin. B-net is very small. So since the magnetic field is small, the machine is unsaturated and is linear. Ayan. So anong ibig pong sabihin neto? Kung maglalagay po kayo ng angle dyan, if that is, tama, magka-cancel siya kasi nasa parallelogram na siya eh. No? So kung kukunin nyo ang B-net, mas liliit na siya. Kaya magka-cancel po siya based on the phasor diagram. Yan, and then so from the both tests we can find the internal machine impedance, or so from the EA OCC at saka si IA from SCC. So ang XS po natin, that is equal to EA over IA, or that is the magnitude of RA squared plus XS squared. So ang XS po natin, so since XS is much greater than RA, pwede nating sasabihin na ang XS natin could be equal to EA over IA. So VOC po natin, V phase open circuit po natin over IA could be also done, no? So therefore, the approximate method for determining the XS at a given field current is to get the internal ito po yung step po na kukunin nyo, no? Kasi ang pinaka-final lang naman na tinatanong sa inyo is the value of XS. What could be the possible value of XS? No? So, get the internal generated voltage, EA, from the OCC. So, gamitin po ninyo yung OCC. Balikan po natin yung OCC po natin. Ayan, OCC. Ayan po siya. So, EA is equal to V phase. Pwede po ninyong gagamitin yan. No? And then, short circuit ninyo para makuha nyo yung IASC po ninyo. Ayan, IA. Ito. Target nyo kunin si IA, so gamitin nyo si SCC. This is the equation of IA. Kung magnitude lang kailangan ninyo, ito ang gagamitin ninyo. No? So kung hindi nyo kailangan na ang angle, pwedeng gamitin nyo na yung IA is equal to EA over square root of RA squared plus XS squared. And then, find XS by applying the equation above. Either of the following, no? So, EA over IA, approximately equal lang to, ha? Saka VOC over IA. Kung kukunin nyo ang exact value, you may use this one. This is the approximate value only, no? Problem with this method, so EA is taken from the OCC whereby the core could be partially saturated. Pwede rin, no? For the large field currents, while IA is taken from the SCC where the core is not saturated at the field currents, no? Therefore, EA value taken during the OCC may not be the same the EA value. Tama, no? Kasi ang nangyari kanina, saturated yung current natin sa large field currents. And then yung sa SCC naman natin nabanggit din dyan na hindi siya saturated. That's why it's linear, no? So, ang AA natin will not be the same. So, the value of SCC, hence the value of XS is only an approximate value. Nagkakaintindihan po ba? Approximate, hindi po siya yung actual, hindi po siya equal. but it's an approximate value. Malapit siya sa value na yan. Kakaintindihan po ba tayo? Yes or no? Kakaintindihan po ba?
Yes, ma'am.
Naintindihan po ba? Yes or no?
Yes, ma'am.
Okay? So, hence, if you are going to gain better accuracy, the test should be done at the low field currents, which looks at the linear region of the OCC test. Tama, no? Para pareho silang linear. But then to find out the resistive of the element of the machine, it can simply be found by applying the DC voltage to the machine terminals of the rotor's stationary. Value obtained by the test RA may increase with the XS accuracy. So mas maganda na kunin na lang natin yung value ni RA para pwede nating magamit yung formula na isa kanina dun sa taas niya. Para accurate siya. Ayan, eto po. Kunin natin yung value ni RA. So, paano natin kukunin ulit ang value ni RA? It said na pwede tayong mag-apply daw ng DC voltage to the machine terminals with the rotor stationary, and then we can obtain the value of RA. So, I hope may example yata to later on, no? To do that one. So, short circuit ratio. What's the definition of this one? Ayan, meron pala tayo dyan na example, no? So, ratio of the field current is required to the rated voltage at open circuit of the fields required for the rated armature current, and at short circuit. Yun po yung short circuit ratio na tinatanong, no? That is the ratio of the field current tsaka yung required rated voltage at open circuit to the field current required for the armature current at short circuit, no? So for example, we have there a 200 kVA, 480 volts, 50 Hz Y-connected synchronous generator with a rated field current at 5 ampere was tested, and the following data are taken, no? I'll just copy this one. Ayan. Wala pala yung solution yun dito, no? Screenshot na lang natin. Pasensyahan nyo na ha, maingay po yung aso ng kapitbahay. Hindi po namin yan aso. Kapitbahay po namin may aso yan. Baka sabi nyo ang ingay naman ng background ni ma'am, no? Pagpasensyahan nyo na po. Hindi ko naman po maano kasi nasa kabilang bakod. Charot. Okay, so here's the problem. Okay, how are we going to solve for the armature resistance and the approximate ohms that would be used at the generator model at the rated conditions, no? So first, we're going to take note, ano po yung mga given po natin? At saka ano yung unang target natin dyan? Ito ang hinahanap, no? Dalawa lang hinahanap, armature resistance and tawag dito, the approximate value of the synchronous reactance. Yun po yung tinatanong, no? So, paano natin mahahanap si RA at saka si XS? RA at saka XS. How are we going to find that one? So, sinong uunahin natin? Si RA po ba o si XS? Based dun sa na-discuss natin kanina, ano ang unahin po natin na hahanapin? Iba pala yung nakapresent, sorry. Ayan. Ayan, paano natin hahanapin ang value ni RA at saka ni XS? Ano ang unang gagawin po natin? Anong unang hahanapin po natin?
Current, ma'am.
Po,
Current, ma'am.
value ni current. How are you going to solve for the value of current?
KVA over square root of voltage, ma'am.
That is IA. IA ang ilalagay ko. So that is equal to KVA divided by ano?
Square root of voltage, ma'am.
Po,
Square root of 3 times the 480 voltage, ma'am.
bakit the square root of 3 ng 480?
Ma'am, para makuha yung phase voltage, ma'am.
Ayan, tama yung sinabi po ni Mr. 200 kVA. So what's the value of the IA? You may type to our chat box, no? Titingnan ko na lang po doon. Para hindi po kayo, ano. Thank you so much na nag-type na ng answer po niya.
Ma'am, yung KVA po ba i-convert pa ng volts?
What? Hindi po
Yung-
natin ma-convert yung...
Ay, kasi 200 na lang po siya basta.
200,000 nata.
200,000 since that is in kVA. Ang kVA po natin, that's the value of S. Saglit lang. IA that can be solved from saglit lang na kung bakit square root of 3? Square root of 3 times 480 ba talaga, Mr. Miguel? Considering it's Y connected?
Yes, ma'am. Yan po yung pagkakalam.
Ay, yun lang. So, kung sakali na if you're going to, pero usually kasi
Ma'am,
mga
kasi
given
terminal po
condition,
yung pan natin. Terminal po yung voltage natin.
S over T, VT, IA. That can be solved. Ang IA natin, pwede natin siyang ma-solve from, from EA. Ano yung equation natin kanina dito? Sa PDF, pwede niyong balikan na lang, no, sa PDF po ninyo kung na-download siya. According sa equation natin kanina, pwede siyang ma-solve from eto, EA over RA divided by JIXS over RA plus JXS. Yan yung equation natin kanina, di ba? Yan yung paghuha dyan. So, ang problema natin, paano natin ma-determine kung anong value ni EA? Anyone? Paano natin ma-determine ang value ni EA? Or yung internal generated voltage natin, paano natin makukuha ang value niya? That is equal to, ang EA natin, dun sa PDF kanina, balikan niyo lang siya. Si EA natin, sabi niya kanina, dun sa may OCC po natin, ayan, ang EA po natin can be determined when IA is equal to 0 and EA natin is equal to V phase. So, ibig sabihin, kung babasahin po ninyo dito sa problem po natin, Ang V-terminal natin sa OSI po natin, that is equal to rated IF, measured to be 540. Naintindihan po ba? So, ibig sabihin, VT po natin at OSI, VT at open circuit, that is equal to 540 volts. Kung kukunin natin ngayon si EA, since ang EA natin that is equal siya sa V phase ng open circuit natin, that can be solved from the V terminal po natin which is 540. Since that is Y connected, ano ang gagawin natin? Equal po ba ang V terminal natin at saka V phase po natin? Or are we going to multiply or divide the voltage? Anong gagawin po natin?
Divide po ng square root of 3.
Ayan. Tama po si Miss Kanaman, no? So we are going to divide it by square root of 3, no? So that is now the value of EA. EA. Yan. 540 over square root of 3. Ano po ang magiging value po natin dyan? According to everyone, that is 311.7691. 311.7676. 91, no? 7691 volts, no? Okay, next. Ano pa ang kailangan natin dyan para malaman natin ang value ni IA?
Ma'am, kapag Y connected po ata yung value ng IA is equal sa value ng IL?
Tama? May point si Miss Yanaban, no? So, ano ang gagawin natin ngayon? Dito, sa IL natin at pwede naman natin mahanap yung IL natin, no? 300 amperes. Bakit ba hinahanap po kasi yung IA?
Given na po yata yung IL?
Oo, tama, no? Given na po ang IL po natin. So, ibig sabihin, ang IL po natin, that is equal to, ano? That is equal to, pwede po natin siyang mahanap from, eto, short circuit test. Ayan. So, yung sinabi ni Mr. Miguel kanina, we're going to void that one, no? Ayan. So, ang IA natin ngayon, that is equal to, ISC po natin, I line of SC. Since this is Y connected, equal po sila, no? So, that is 300 ampere. So, okay na tayo sa IA, EA. Ano pang hahanapin natin? So, ang hahanapin natin is armature resistance at approximate value ni reactance. So, kanina nabanggit dun sa may module ninyo na pwede daw nating mahanap si, sino? Si RA if we are going to, anong gagawin po natin? We're going to sabi niya dito kanina, we're going to apply a DC voltage to the machine's terminal with the rotor stationary to obtain the RA natin. Kasi RA tsaka si XS naman hahanapin. So to perform that or to calculate that one, ano ang gagawin natin? Saan tayo kukuha ng VDC po natin or DC voltage po natin? Okay, so dyan sa number 3, meron siyang nabanggit dyan na when a DC voltage of 10 volts was applied to two terminals, the current of 25 ampere was measured. So using the Ohm's law, paano natin gagawin yan? So that is equal to RDC po natin or RA, that is equal to VDC over IDC, tama? But since dalawa po, yung dalawa po, yung dadaanan po niya na wire, So, ibig sabihin that will be twice. Naintindihan po ba? Yes or no? So, kung gagawin po ninyo yan, bakit twice siya? Based on the circuit alone, saan siya dadaan? Dalawa na wire. Kaya naging dalawa rin yan. Nagkakaintindihan po ba tayo? Yes or no?
Yes, ma'am.
Kaya 2, twice of RA. Kasi dalawa yung dadaanan niya eh. DC siya. So dadaan siya sa dalawang windings niya. So that is twice of RA, which is equal to VDC at saka si IDC. So if we're going to evaluate this further, no? So ang RA po natin, that is equal to VDC over twice ni IDC. So pwede ba nating mahanap na si value ni RA? Yes, no? So VDC po natin is 10 volts divide ng twice of IDC, which is 25 ampere. So what is now the value of RA? According to Ms. Nariza, Cyril, 0.2. Ayan. So 0.2 ohms, no? 0.2 ohms. So RA, tapos na tayo. Nahanap na po natin. Yan na siya. No? Okay na yan. If we're going to solve for the approximate value of reactance, paano naman natin ngayon hanapin? Ang sabi kanina, no, XS can be approximately calculated from EA over IA. Tama po ba ako? Approximately, no? So that is equal to EA. EA natin is equal to, ito, 311.7691 volts. Divide nyo siya kay 300 ampere. So what is now the approximate value of XS? Yan, pakisolve po siya. Sabi ni Miss Hannah, 1.0392. Yan, perfect. So that is 1.0392 ohms, no? So yan na po yung value po ni XS po natin. Kasi approximate value lang naman ang tinatanong. Ayan. Any questions, clarifications pa? May mga tanong po ba?
Ma'am, saan ko na yung 540 volts?
yung 540,
Yes po.
galing siya kay VTOC po natin. Yung number 1, terminal voltage at open circuit. Kasi 'di ba na-mention kanina na pagkukunin natin yung EA natin, pwede natin siyang equate from V-phase OC po natin. Ito po siya. Saan na ba yun? Open circuit test. Ayan. Ayan, eto po. Galing po siya dyan. Si EA natin, that could also be equal to V-phase during OCC. Kapag ang IA po natin is equal to 0. Naintindihan po ba? Naintindihan po ba? Yes or no?
Ma'am, bali given po siya sa problem.
Yes po. Given po siya kanina.
Ay, sige po. Salamat po.
Sige lang po, no problem. dito po siya nakalagay kanina. So number, saan na ba yun? Dito. Ayan. So, data are taken from VT po natin is equal to ito. Ayan po yung data na nakuha during the OCC. No? Open circuit. OCT. Open circuit test. No? Okay, so how about naman? Yes po, Mr. Miguel?
Pag no load condition lang po ba yung equal sa VT, ma'am, yung EA?
At IA is equal to 0. And let's see kung nabanggit niya na no load. It is possible that the plot is ito, tama, no load connected at the terminals. Wala siyang load i-connect sa terminals during the OCT. No? Open circuit test, wala kang ilalagay na load. And so mapapansin mo dyan is, ganun talaga siya. Kasi unang-una pa lang nung nag-discuss tayo, ginagawa natin na ang EA natin is equal to V phase. Wherein, walang load yung generator natin. Wala ring losses dun sa may stator natin, dun sa may magnetic field para mabago siya. No? Okay na ba, Mr. Miguel?
Yes, ma'am.
Okay, any more questions, clarifications? Wala? So what if naman tinatanong niya what will be the actual value or what will be the exact value of the XS. So to do that one, pwede natin siyang kunin sa isa pang formula po natin kanina na yung EA, ayan, EA over IA that is equal to ZS, tama? ZS. Or yung ZS natin that is equal to square root of RA squared plus plus GXS plus XS squared, di ba? Pwede din yan. Ayan. So, EA natin kanina, balikan lang po natin, that is equal to 311.7691. 311.7691 volts. Divide natin siya to 300 ampere. The value ni current natin. So that is equal to square root ni, anong value ni RA natin kanina? That is 0.2 if I'm not mistaken. Plus XS squared. No? You may use your calculator. Pwede nyo siyang shift solve na lang. Or pwede natin siyang i-simplify. No? Square both sides para matanggal yung square. Ayan. Then pag in-square nyo siya, so 311.7691 divided by 300 ampere, quantity square, so that is equal to 0.2 square plus XS square. And then transpose to kabilang bangir, so ang XS squared po natin, that is equal to 311.7691 divided by 300 ampere, quantity, square ninyo siya, then ito, transpose nyo, so magiging negative 0.2 squared. And then, take the square root of both sides. Ayan, para matanggal yung square doon, no? So, that is equal to XS now is equal to square root siya ng, ayan, banking na yung line ko, sorry. Ayan. So, 311.7691 divided by 300 ampere, quantity squared plus 0.2 squared. So, calculate ninyo yan. Ano ang magiging actual value ni XS? Pwedeng shift solve sa calculator nyo. Pwede nyo i-type naman kung ano yung nandun sa XS kanina. So, according to Ms. Larugal, 0.998, 1.0198. Ayan. So, halos the same naman po kayo lahat, no? So, that is 1.0198. 1.0198. 0.0198 ohms, no? So kung mapapansin ninyo, yung excess natin kanina, ayan, ito po siya, approximate value. So halos equal naman siya, point something naman ng difference, no? And then ito yung actual po natin. Ito yung approximate value naman. 1.0392 ohms. So, parang malapit na, di ba? Kasi ang sabi niya, since ang excess natin is much, much larger than the value of RA, so parang negligible na siya. Parang negligible lang, pero maliit lang talaga ang value ni armature resistance. So, in-equate niya yung EA natin equal siya kay IA. No? Okay? Any questions, clarifications? So, ganyan po yung pagkuha ng approximate value ni XS, the value of RA, at siya si actual value ni armature reactance. So, kung i-drawing po natin yan, no? I-drawing po natin yan, ganito po ang magiging figure po natin. So, that is now the value of EA. We have here the resistance RA, tsaka si JXS po natin. And then, yung V terminal po natin. V phase to, kasi single lang kinuha ko, no? So, this is EA. This is the value of RA, tsaka si JXS, no? So, that is 0.2. This is either, no? Kung ano yung actual, ilalagay nyo 0192 yata yan. So, ang EA naman natin is 311 point something angle of, we do not know. Since this is EA at saka si V phase, so ang gagamitin nyo dito is si, theta ba, gamma, o si sigma? Anong gagamitin yung angle po dyan? Or the correct? That will be now the angle of, the angle of the sigma, no? Degrees. And this now will be now the value of our RF. Ayan. Field current, which is a variable. This is now the LF, RF, and this is now the supply to our field, no? VF. Ayan. So, ganyan na po yung magiging figure po natin no? If you're going to redraw what you have solved, no? Kakaintindihan po ba tayo? Naintindihan po ba? Any questions? Clarifications?
Ma'am, parehas din po ba sila sa delta?
Delta. Ang mangyayari kapag delta na, okay, so kung gagawin natin ito na delta connected, yan. So, yung VT natin, 540. So, kung kukunin natin si V phase natin, since connected siya as delta, ibig sabihin, magiging, equal na yung value ni V terminal natin sa OC at saka V phase natin sa open circuit is equal. Tama? Magiging 540 na lang siya. Tsaka si line current natin is magbabago naman siya.
Bali sa readings po magbe-base, ma'am.
Po?
Sa may readings po ng open circuit na voltage at short circuit.
Yes po. Doon na po tayo mag-base. Sa short circuit, sa open circuit, if that is Y connected, if that is delta connected, ang target lang natin na malalaman dyan is the value of our RA at saka si JXS. That is why it is called the parameters. Finding the parameters of our generator.
Sige po, ma'am. Thank you.
Yes po. Any more questions, clarifications po? Thank you so much. No? Very interactive ngayon ng mga estudyante po natin. Nakakatuwa lang. Any more questions? Wala na yata, no? Okay, so magmo-move on na po tayo. Moving on. Ilan pa ba to na topic? Nine. Kailan ba ang midterm ninyo? Saglit, check ko lang kung kailan midterm nyo, no? Para ma-discuss natin hanggang sa elective machines. Ang midterm ninyo, probably, I'm not sure, pero ang sinasabi nila is face-to-face yata ang mga major exams nyo. April 28. April 28. So, tentative na exam po ninyo will be April 28. So, ilang meetings pa tayo? So, if we're going to discuss 8, 9, 10, 11, 10. So, 15. Tapos, mahaba pa. Okay, so last topic na lang siguro tayo, no? Let's continue our discussion with the ano ba tayo? Number 8. Ayan, synchronous generator operating alone, no? Loner yung generator natin. So, if that is the case naman na operating alone lang yung generator natin, so the behavior of synchronous generator under load varies greatly depending on the power factor of the load and on whether the generator is operating alone or in parallel with the synchronous generator, no? So, we're going to disregard the value of RA, and the rotor flux is assumed to be constant unless it is stated that the field current is changed, no? So also the speed of a generator will be assumed to be constant, and all terminal characteristics are drawn assuming constant speed, no? So what is the effect of the load changes in the synchronous operating alone? So assume natin na meron ng connected na load. Ano ang pwedeng magiging changes lang? Either it's going to increase yung load po natin, no? So an increase in the load is an increase in the real and the reactive power drawn from the generator. So such a load is increases the load current drawn from the generator. Ang ibig sabihin lang nito, no? So habang dinadagdagan ang value ng load mo, or parang kung baga gagawin mo lang mabigat no? Kung gagawin mo siyang mabigat yung load mo, it will parang kailangan niya ng mas malaki na power para may either kung if you are going to have to ano bang ibig sabihin nito. So kung magdagdag ka for example sa generator, magdadagdag ka pa ng isang household, no? Gawin mong 2 household yung kukuha ng power doon. So ibig sabihin dagdagan mo naman yung power para ma-compensate niya yung buo. Maloadan niya yung buo. For example, 3 bahay ang bibigyan mo ng power. Diba? So dati, ang sinusuplayan mo lang 2 bahay. Sabihin natin 2 bahay. Ngayon, dumating yung pinsan mo, nakikabit sa'yo, ibig sabihin, dagdagan mo pa yung power na kailangan. So with the increase of the power drawn from the generator, no, there is also increase of the load current. Magkakaintindihan po ba tayo? So if you are going to assume that the field resistor has not been changed, the field current is kept constant, so ibig sabihin yung flux natin is constant. So ang nangyayari lang naman dyan, no, ang flux natin is based on the field, no? And then, if the generator or rotary speed is maintained, ibig sabihin ang EA natin is constant. Yun po yung mga assumptions po na ginawa dyan. No? So if EA is constant, what actually varies with the changing load? Initially, yung lagging load po natin, load is increased with the lagging power factor maintained. So magnitude po natin of IA will increase but will maintain the same angle with the reference of V phase. This is due to the power factor is maintained lagging. And then so excess IA natin will also increase and maintain the same angle. Since ang EA natin sa kasi V phase, EA natin that is the total of V phase plus JXSIA. So from the phasor diagram po natin, so JXSIA must be stretched between the V phase and the angle of 0 para at saka at angle of 0 para kay IA natin so kasi V phase. So which is constrained to be the same magnitude as before at the load increase. So you're going to note here that the EA has remained constant. And hence, only element which would change and compensate would be V phase. So this change may be seen in the phasor diagram. And so ito po yung effect na sinasabi niya. So the effect of an increase in generator loads at constant power factor upon its terminal voltage, which is lagging power factor. Ayan. So, EA po natin originally, ayan. And then, eto, IA. So, ibig sabihin ng maintain ng IA po natin. So, E prime EA po natin, siya po yung nag-move. Na-stretch po siya, that is just to compensate. No? Yun lang po yung gagawin po dyan. And then, initially, unity load. Kapag unity load naman tayo, the load is increased with the unity power factor maintained, so the magnitude of IA will increase but maintain the same angle with the reference of V phase that is due to the power factor is maintained at unity, no? Okay, so the magnitude of IA will increase, no? And then the XSIA will also increase and maintain the same load angle. And then note here that the EA has to remain constant. Then hence the only element that would change to compensate the V phase And this change may be seen in the phasor diagram. So anong nagbago lang po dyan? Na-stretch yung EA natin, nagbago, tumaas lang siya. Ayan, na-stretch din yung IA po natin. Yun po yung ibig po niyang sabihin. Ang na-stretch po dyan is si IA, nag-increase lang po siya. So that is the effect of increase of generator at constant power if you are going to maintain at unity power factor. Yun po yung ibig lang po niyang sabihin. And changes in V phase would be decreasing but it would less significant as compared to the load lagging. So pag leading naman, ang na-stretch po dito is the IA also. Same din lang naman, na-stretch lang yung IA. Nilagay lang po dyan yung mga figures, no? Same din lang. So, voltage regulation tayo. So, for the voltage regulation, for lagging loads, VR would be positive. Kapag leading loads naman, VR is negative. For unity power factor would be positive. So in practical, it is best to keep the output voltage of generator to be constant. Hence, EA po natin has to be controlled, which can be done by controlling the field current IF, varying IF, which will vary the flux in the core, which then will vary the EA according to the OCC po natin, no? So how much generator field current be adjusted to keep VT as the load changes? VF, tignan natin yung VF or IF. Wala naman siyang nabanggit. Ayan. Then, another example, I guess. We have the 480 volt, 60 hertz, delta connected. Synchronous generator has an OCC as shown below. So the generator has a synchronous reactance of 0.1 and then the armature resistance of 0.015. At full load, the machine supplies 1,200 ampere at 0.8 power factor lagging. Then the under full load conditions, the friction and windage has losses of 40 kilowatt and the core losses are 30 kilowatt. So you are going to ignore the field circuit losses. And then, what is the speed of rotation? And then we are going to answer this one, no? I'll just copy, no? Copyin lang po natin. Naririnig pa rin po ba ako? Tulog na kayo? Natulog na yata kayo? Tulog na po ba ang klase?
Hindi pa po.
Hindi pa po.
Ako sabi yan, boring naman ng teacher namin. Ulit lang ha, copy lang po natin. Wala naman kaming magagawa kundi mag-antay, di ba? Biro lang. Diyos ko. Okay? Yan. Hindi yata kasya, no? Sa bago na lang natin. Bagong slide na lang. Ayaw niyang magkasya. Huwag nating ipilit kung ayaw niya, no? So what is the speed of the rotation of the generator? How much field current must be supplied to the generator to make the terminal voltage 480 volts at no load? So una, paano natin mahahanap yung speed? So given that the 480 delta connected 4-pole generator natin has an OCC as shown. Yan po yung figure ng OCC po natin. So this generator has a synchronous reactor of 0.8, the armature resistance of 0.015, and the machine supplies 1,200 at 0.8 power factor lagging, no? At full load conditions, the friction and windage losses are 40 kilowatt, and the core losses are 30 kilowatt. So initially, the field circuit losses po natin. Ignore the field circuit losses, or that is the field winding po natin, hindi po natin isasali, no? Yung losses doon. So, unang-una, paano po natin mahahanap yung speed rotation daw po ng generator po natin? Paano natin masasolve po yan? How to find the speed of the generator? That is by simply by ano po? That is 4-pole, 60 Hertz. So, paano natin mahahanap? That is equal to? Hindi, nalipatan na maninit. Anong equation natin sa speed? N is equal to? Ano po? Anyone? Anyone but no one? Ano equation po natin para makuha natin ang value ng speed po natin? 120. Ayan, tama yung sinabi ni Mr. Tagaw. That is 120. Yan. Yung magsulat na naman ng pen ko. Ano bang gagawin natin dito? Ayun. Okay na. Tama yung sinabi ni Mr. Tagaw, that is equal to, F is equal to NP over 120, or that is equal to, ano? N is equal to 60 times 120 divided by 4. So that is equal to 60 divided by 4, or 4, 120. That is 3, no? 30. So 30 times 60, that is 18. So that is 1,800 RPM. Tama po ba?
Yes po.
Okay. So next, how are you going to solve for the field current that must be supplied to the generator if the terminal voltage is 480 at no load? So babalikan po natin ulit yung given, no, sa taas po niya. That is, eto. Field. Or 480. Ito, sa figure natin dito. Sabi niya, terminal voltage natin, OCT, ito po, nasa gilid. Ayan. Ayan po siya. And this one is field current po natin. Ang tanong niya dito is, how much field current must be supplied to the generator to make the terminal voltage 480 at no load? So, at the figure or the graph, kung 480 yan, what would be the possible value of the field current? Sa tingin ninyo, nakikita po ba ninyo yung graph? Yes or no?
Yes, ma'am.
Yes po.
So what would be the value of our field current? Sa tingin ninyo?
Nasa around 4.5 po to 5.
Ito, ang 480, divide natin to na, could be, this one is 450 na, no? 50, 60, 70, 80, 90, 100. Malaki yata, no? It could be probably there. Ayan. Sorry, no? It's not a straight line. And this one, pababa. Could be there. No? So, it could either be, since hindi siya straight line, hindi tayo pwedeng mag-ratio, no? Around 4.6, 4.7 sa akin. Sa inyo, sa tingin ninyo, anong value ng IF po natin? Sa akin, no? B. IF would be probably 4.7 ampere. Nasa around po ng 4.7, no? So, how much field current must be supplied to the generator to make the terminal voltage 480 at no load? So, if the generator is now connected to the load and load draws 1,200 ampere at power factor 0.8 lagging, how much field current will be required to keep the terminal voltage to 480? Okay, how are we going to solve or how are we going to find for the field current of letter C? Paano? How? Anyone? That is by anyone po? Paano natin mahahanap yung value ni field current? Anyone that would like to answer letter C? Kaya naman ngayon. Medyo masakit na yun. If the generator is now connected to a load and the load draws 1,200 at power factor of 0.8, how much field current will be required to keep the terminal voltage equal to 480 volts? Paano natin mahahanap yan? Ang tinatanong po dyan is field current. Paano natin malalaman ang value ni field current? Anyone? Someone? Nobody? No one? Paano po? Ano pong gagawin natin? Okay, so ako na lang, no? So from this figure, paano kaya tayo makakuha? E-terminal. This is OCC, no? So since sa OCC po natin, ang sabi po natin is EA is equal siya kay V-phase. Tama po ba? At OC. Tama po ba? So since this is connected in delta, so ibig sabihin ang VT natin at OC is equal sila. Di ba? Yes or no? So since sa tanong dito kanina, sabi niya dito, terminal voltage equal to 480. So ang kailangan nating hahanapin po dyan is the value of EA. So kung si EA po natin, paano po natin isa-solve ang value ni EA? Si EA po natin, that is equal to, given yung mga parameters po niya dito sa taas, ang formula po natin, that is equal to P phase plus IA RA plus JIA XS. Tama po ba? Mga values po ba tayo kompleto? Armature resistance, armature reactance, and that one. And then, ang IA po natin, since that is 1,200, and terminal voltage natin is 480, can we solve for the value of IA? Yes or no? Yes or no? Pwede po ba nating masasolve yung value ni IA? Yes, ang IA po natin, since that is delta connected, and this is the I line, ibig sabihin, I line over square root of 3. Ayan, so that is 1,200 ampere over square root of 3. So that is equal to, what's the value? Or pwede nating gamitin na lang po yan, no? Ampere. So EA po ngayon natin. So ang tanong, what is the V phase? Ano ang value po ng V phase po natin? So that is equal to, nasabi po dyan sa problem na 480 po siya. No? Since V phase is equal to V terminal. Delta connected, no? 480 angle of 0 plus 1,200 over square root of 3 multiplied by RA. So ang RA po natin, that is equal to 0.1 multiplied by 0.1 plus J po natin is 1,200 over square root of 3 ng 0.015 if I'm not mistaken. 0.015 po ba? Tama yata, no? 0.15. But then, I'd like to ask, what is the angle of our current? Ang angle po ng current po natin is, back tayo sa current, is based on the power factor. Since that is lagging, is it negative or positive po ang angle po natin sa current? That is negative since that is lagging, no? So that is cosine of 0.8. So insert lang ninyo dito angle of cosine ng 0.8 negative, and this one insert din ninyo angle of negative cosine ng 0.8. So what is now the value of EA? You may use your calculator kung ano ang value ng EA po natin. Baliktad. Sorry, no? Synchronous reactance and synchronous resistance. So, resistance, baliktad lang naman yung J, no? Tanggalin nyo lang yung J, ilagay nyo dito. Kasi current lang naman yan, no? Ayan, J 0.1. Nagkamali po ako sa binasa, no? So, should be resistance yung 0.015. So, ito po ang reactance po natin. So, what is now the value of EA? Type to our chat box lang po, no? Kung anong value ni EA. Ayan, may sumagot na po, no? So that is 531.5361. Dalawa sila. How about the others? Melchor, Davon, Estrelon. How about the others? Ilan po nakuha nila? According to them, that's 532.1614. Tama po ba? That is 532.1614. Angle of 5.3037 yata degrees. Ayan, no? So if that's the case, meron na tayong value ni EA which is 532. So pwede na po nating tignan dito sa may eto. Ayan. So if that is 532, probably it could be 550. Probably nandito, no? Ayan. Sorry for not having a straight line, no? So if ibababa niyo siya. Ayan. So sa tingin ninyo, what will be now the value of the IF? On your assumption, what is now the value of IF? Anyone? What is now the value of IF? IF now is? Anong masasabi po ninyo? Mr. John Vincent. Naririnig pa rin po ba ako or tulog na kayo? Hello po.
Naririnig mo.
Yes. Bakit hindi kayo ngayon sumasagot? What is now the value of IF? Sa tingin po ninyo? Sa akin, mga nasa probably 5.5 or 5.4 to 5.6 probably. How about you? Or how about the others? Ano sa tingin po ninyo? Sir Miguel.
Nasa 5.5 po.
5.5. Okay, so to be safe, lagyan na lang natin siya as 5.5, no? So, therefore, IF is now probably equal to 5.5 ampere. Okay, so let's move on. How much power of the generator is now supplying? So, P input. How much power is supplied to the generator by the prime mover? And then what is the machine's overall efficiency? So, for letter D, paano natin yan malalaman ang P input po natin? P input natin is equal to or supplied, ano yung tanong? Ay, supplied ba? Or the output already? How much power is a generator now supplying? Ano sa tingin ninyo? Is it input or output yung tinatanong? It's the output, no? Kasi ang tinatanong niya supplying eh, no? So sa letter D po natin, ano ang equation natin for P output? That is equal to 3 ng P phase IA cosine of theta, or it could be either square root of 3 ng V line I line cosine of theta. Okay, ang tanong, ano ang value ng V line po natin? Ano ang V line po natin? That is equal to, ano yung ginamit natin kanina? Sabi niya, ang terminal voltage po natin is what?
480.
480.
480 volts, no? How about the I line? Sinabi rin ba niya? I line po natin. O, ayan. Ayan, 1,200. No? So that is 1,200. How about the power factor or cosine theta? Binigay din, no? That is 0.8. So substitution, P output, that is equal to square root of 3 ng 480 multiplied by 1,200 multiplied by 0.8. So what is now the value of P output? That is 798.1279. volts, no? And next question, how much power is supplied to the generator by the prime mover? So, ang tinatanong is, supplied by the prime mover, or ano yung tinatanong dyan exactly? That is the, ano ang tinatanong dyan? Or the supplied by the prime mover. That is the, yung tinatanong na yung supplied by the prime mover, yan na yung P input po natin. So, if you're going to solve for that P input that is equal to P output plus P losses. No? Ano yung losses natin? P losses is equal to, ano po yung losses natin? Based on the power flow diagram, kailangan natin yung, ano po? Core losses. Kailangan natin yung copper losses. Kailangan natin yung stray load losses. Ano pa yung mga losses na nailagay dyan?
Friction po.
Kailangan natin ng friction and windage. Kailangan natin yung mechanical, yun na yung friction and windage niya. Core losses, meron na rin. Copper losses, wala, no? Tama? So, isulat lang po natin, no? Ano yung mga losses na kailangan natin? That is the, unahin natin, P stray power losses, no? SPL, plus P core losses, plus P friction and windage, plus, ano pa yung losses natin dito? Dun sa una, no? Sa power flow diagram natin, this is P input. Ano yung una dito? PSPL, di ba? Stray losses.
Yes
Plus,
po. Friction.
P friction and windage dito.
Opo yata.
Tapos ano pa?
Or,
Ano yung nandito na isa? P core. No? Tapos ito na yung P converted, di ba?
yes
Tapos
po.
meron dito yung P copper. Ayan. Memorize nyo to ha? Tsaka P output. Ganyan yata siya, no? So, ang wala lang dito, okay na tayo sa friction windage, core losses, wala namang nabanggit na SPL kahit hindi nyo nakunin. Meron ba o wala? Wala naman yata. Wala, no? Walang SPL na nabanggit or yung stray losses, wala, no? Negligible siguro kasi baka maliit lang masyado, no? So, ang kailangan lang natin is P copper losses. Okay, ang tanong, paano natin makukuha ang copper losses? Or that is the I squared R losses, di ba? R squared R losses, di ba? Yes or no? Or that is the IA squared RA losses. Ayan. So, kukunin natin yan. So, P copper po natin, that is equal to, anong value ng IA po natin? That is 1,200 over square root of 3. Tama po ba? Then quantity square natin. How about the value of RA? Balikan po natin. Ang RA po natin is, eto, 0.015. Ayan. So 0.015. So what is now the value of P copper? Ilang watts po siya? This is just the per phase po niya, no? Pero since kung i-direct na natin, since that is 3-phase, multiply niyo siya ng 3. Kasi per phase po ang kinuha natin dyan. Gawin niyo siyang 3. Ayan. So 3 times ay 1,200 over square root of 3 quantity squared times 0.015. Since, please take note, no? This is 3-phase. Hindi po tayo kumukuha sa single phase, no? 3-phase po yung calculation po natin. So what is now the total, no, na copper losses po natin in 3-phase? according to Tagaw, that is 21.6 kilowatt. Ayan. Exactly po ba? So, lagay ko na lang po siya na 21.6, no? 21.6 kilowatt, no? So, okay na tayo, no? May copper losses na tayo, may core, friction, windage. So, P input. Ano ulit ang friction and windage natin? That is, ang sabi dito is 40 at saka 30 ang core losses. So, that is 40 kilowatt. And this one is 30 kilowatt. So total no ng P input na natin, that is equal to P output, which is 798.1279 watts plus 40 kilowatt plus 30 kilowatt plus 21.6 kilowatt. So what is now the total P input? Ay, tanong ko nga, watts lang ba yung nakuha ninyo dun sa may ano?
Kilowatts na po ata yan, no?
Kilowatt
Ay,
po yun.
kilowatt. Okay. Gawin niyo pong kilowatt rin ito. Kasi parang 798, kung tutusin mo kilowatt lahat yan, parang ang liit. Di ba? Di ibig sabihin, wala pang kalahati yung efficiency natin. So what is now the value of P input? According to Miss Christine, 889.70 to 79. So that is 889.7279 kilowatt, no? So efficiency, madali lang naman ang efficiency, di ba? P output over P input. So ano na ang efficiency po natin? Times na lang siya ng 100%. Yan. So efficiency po natin, that is equal to ang value po ng efficiency po natin. $89.6903. 89.6903%, no? So that is not the efficiency of our generator. So any more questions? Meron pa ba? May mga tanong po ba? May tanong po ba before we are going to continue discussion? Okay, so if none, so next question is, if the generator's load were suddenly disconnected from the line, what would happen to its terminal voltage? Ano kaya ang sagot ninyo dito? Sa tingin ninyo, anong mangyayari dyan kapag tinanggal daw po natin yung load na connected dyan, suddenly? Biglaan yung tatanggalin yung generator. Generator. Yung load pala. Sorry, gutom lang ako.
Tataas ang voltage niya.
Po? Ano pong mangyayari dyan?
Tataas ng terminal voltage mo.
Tataas ang?
Terminal voltage mo.
Ayan, tama po. May point po si Mr. Miguel, no? Tataas po ang terminal voltage po natin, no? So if the generator is load or suddenly disconnected from the line, the current IA would drop to 0. Magiging 0 po ang, ang IA po natin, and dun sa OCC po natin, magiging EA po natin is equal to V phase. And then since ang field current naman natin hindi rin nagbago, so ibig sabihin, ang EA natin hindi rin magbabago. So ang terminal voltage lang po natin ang magbabago, which is magiging equal na siya kay EA. Wherein yun yung na-calculate natin kanina, which is 532 point something, no? Okay, so sa letter F po natin, ang tanong po dyan is, suppose that the generator is connected to a load drawing 0, then how much field current must be required to keep the VT at 480? So, ang tanong naman dito ngayon, paano natin makikip na yung terminal voltage natin is 480? So, kukunin natin ngayon ulit, yung parang ginawa po natin kanina, yung value ni EA. Ayan. No? Ito din lang gagawin natin. So, kunin nyo ulit yung value ni EA. So, perform this one for letter F. So, perform again this one. So, what is the value of EA? Tayin ko po, no? Kahit 10 minutes hanggang 11 before we are going to have the lunch. Just type to our chat box pag natapos nyo po siyang i-calculate, no? Ano ang bagong value ng EA po natin? So, gamitin po ninyo na yung V-terminal daw po natin 480. Ayan. So, kung 480, palitan nyo ito ng 480. Bakit 480? Leading pala. Nagbago lang po yung power factor po natin. Gawin nyo lang po siyang leading. So, ito, gawin yung positive cosine ng 0.8. Yun lang po yung gagawin ninyo. What is now the value of EA? Palitan ninyo yung power factor lang po. Gawin nyo siyang leading power factor. Then same din lang, 480 plus, ayan, same din lang. And then positive na po ito, magiging positive po yung cosine. So please calculate and type our chat box kung ano po yung value ng bagong EA po natin. Ayan, may nag-type na po ng mga sagot nila. We have Carl Patrick, sabi 450.9799, 450.97. Okay, so from that, no? If you're going to use the figure, 450, kamo na lang nasa 451, no? So dito, 451 siya. Approximately nasa gitna siya, no? 450. Sa gitna siya dito. Parang andito, no? Nasa 4 siya o kaya pagitan ng 4.1 or 4. Somewhat 4.1, no? Either no. It could be 4.1. Sa akin lang, no? Ang IF, so from the figure, it could be 4.1 ampere. Ano? So, yan po yung magiging value ng IF po natin. Naintindihan po ba? Any clarifications po? May mga tanong po ba? Any clarifications po? So, if none, let's call it a day. And ingat po tayo maghapon. Wala na pong mga tanong, no? Bye everyone.
Bye, ma'am. Thank you po.
Hi, ma'am.
Ay, ma'am. Thanks.
Thank you
Bye,
po.
ma'am.
Thank you, ma'am.
Bye, ma'am. Bye, ma'am. Ma'am, di, tara.